Okay, so I finally gotten to start the video lecture here on naming. We'll start with carboxylic acids. It's pretty straightforward. You just replace the E of the alkane. Okay, so for example here, methane, CH4. I'm going to replace the E with a carboxylic acid with the same number of carbons, and instead put oic acid. So instead of methane now, if we look at the carboxylic acid, it would be methanoic acid. Okay, methanoic acid. IUPAC naming is what we want to go by, but at least for methanoic acid and ethanoic acid, I want you to know the common name as well. So the common name here is formic acid. Okay, methanoic acid or formic acid. This carboxylic acid has 2 carbons, so it comes from ethane. It's ethanoic acid. And we should all know its common name. It's acetic acid. Let's look at one now that's a little bit more difficult. But it's not bad if we use our IUPAC systematic approach. We start our numbering at the carbonyl carbon. So there's carbon number 1, 2, 3, 4, and 5. So the parent compound is pentanoic acid, and we got a bromine or a bromo substituent at the 3 position. So it'll just be 3-bromo, pentanoic acid. So let's continue on here. Let's name a few more carboxylic acids and then shift to acyl chlorides or acid chlorides. I put them together on purpose so you can see that we name them very, very similar, or similarly. So if we start our numbering with this more complicated acid here, carbon number 1 at the carbonyl carbon, our longest chain, has 7 carbons. So it'd be heptanoic acid. And then we have a methyl substituent at the 3 carbon and a methoxy substituent at the 5 carbon. Okay. So let's see, methoxy or methyl. I think methoxy comes first alphabetically. So it would be 5 methoxy, 3 methyl, heptanoic acid. Methoxy 3-methyl heptanoic acid. It's a little bit different when the carboxylic acid is directly attached to a ring. Okay, what we do here is we just write the name of the ring. So this is benzene. Okay, and then we say carboxylic acid. Benzene, carboxylic acid. So the benzene carboxylic, just one word. Here, we don't have to worry about numbering. We assume that this is number 1. Where the carboxylic acid is attached to the ring is carbon number 1. So when we have a substituent here, 1, 2, 3, so an ethyl at the 3 position, that's a cyclooctane ring. So it would be 3-ethyl, 3-ethyl cyclooctane carboxylic acid. Three-ethyl cyclooctane carboxylic acid. Okay. Now, shifting from the carboxylic acids to the acyl chlorides, that's all I did here. I got the same compound up here just as down here, just the acid chloride version. Okay. So instead of the ic acid, so heptanoic acid, we're going to change this portion with eel chloride. If there's a bromine there, it'll be eel bromide. So we're going to name it exactly the same. 1, 2, 3, 4, 5, 6, 7. So It's not heptanoic acid as our parent chain, but heptanoyl chloride. And then we've got 5-methoxy, 3-methyl, heptanoyl chloride. Okay. I'm going to erase that name, so pause it if you need to and write it down, but I'm going to erase it so I can write the next one. I'm running out of room. So this is the acyl chloride version of benzene carboxylic acid. Okay? So instead of the carboxylic acid, we're just going to say carbonyl chloride. So benzene, carbonyl chloride. Okay. Take a second and try and name the last one. So this is the one position again, 2, 3-ethyl. Okay. Cyclooctane carbonyl chloride. 3-ethyl cyclooctane carbonyl chloride. So let's move now to esters. Let's move to esters. So just pause it if you need to write everything down. So naming esters. Remember, an ester has the generic structure that looks like that. Okay, looks like that. So we've got two portions. We've got two R groups. We've got the R group that's attached to this oxygen, and then the R group that's attached to the carbonyl carbon. We've got to name both of them, or include both in our name. So the acid portion is going to come from here, and instead of saying ic acid or carboxylic acid, we replace ic acid with 8. With 8. Okay? And then we just simply name this ethyl, methyl, propyl, whatever it might be. And we state it first. I think that's a lot of wording for a simple process, so let's try one. So let's look at an example here. So we're going to state first whatever is attached to the carboxyl oxygen, which is right here. This is an ethyl group. Okay. Our acid portion has 2 carbons. So if it were carboxylic acid, it would be ethanoic acid. Okay. But here, since it's not the acid, we replace the ic acid with 8. So ethyl ethanoate. If I said that right. Okay. Now you need to know the common name for this because you use it in the lab all the time. It's ethyl acetate. So ethyl, and then the common name of that acid is acetic acid, so ethyl acetate. Let's try another one. Pause it at any time and try and name it on your own, or catch up if you're writing. Okay. So we got to name what's attached to the carboxyl oxygen first. The oxygen is directly attached to a phenyl ring or benzene ring. So that is phenyl. That substituent is phenyl. Okay. And then our acid portion has 1, 2, 3 carbons. So it'd be propanoic acid. We replace the ic acid with 8, so propanoate. Phenyl, propanoate. Okay. Now keep in mind here the difference between phenyl and benzyl. So if there's a CH2, it's not phenyl, it's benzyl. So this compound would be named benzyl propanoate. Alright. Let's do one more. Let's do one more. Okay. So what's attached to the carboxyl oxygen is ethyl. Our acid portion has 3 carbons. Number 1, number 2, number 3. We've got a chloro at the 2 position, so ethyl, 2-chloro. What? Propanoate. All right, now we name carboxylic acid salts or carboxylates similarly. So let's say acid salts are named like esters. Okay. Acid salts are named like esters. Here's an example. Okay. So this would be the product that we get if we reacted butanoic acid with something like potassium hydroxide. We get the potassium salt. Okay. So what is bonded or interacting with the carboxyl oxygen? Is potassium, right? So just write potassium. And then the acid part, 1, 2, 3, 4 carbons, butanoate, potassium butanoate.